Right, in this lesson, we're looking into trigonometric identities. So you're going to learn some new identities about trigonometry, obviously involving the reciprocal ones, because we're learning reciprocal trigonometry functions, and we'll put identities in there. Obviously, we have new identities about reciprocal trig. So first of all, as a first exercise, can I ask you, can you recall, write down as many trigonometric identities that you have learned or you could remember? Okay, there are only two. So the first one, okay, is they're not in any order in particular. The first one, we know tan theta equals sine theta over cos theta. Okay, and the second one is sine squared theta plus cos squared theta equals 1. All right, so these two are what you've learned before. So you're going to learn two new ones. All right, first of all, the first one is they're quite similar. So if you remember the first one, you can easily remember the second one. The first one is 1 plus tan squared theta is equivalent as an identity to sec squared theta. So 1 plus tan squared is equivalent to sec squared theta. Now the next one, quite similar to this one, we'll also start with 1 plus, and then the tan squared becomes cot squared theta, and then that's equivalent to cosec squared theta. So why do I say they're similar? Well, one, they're structurally they look the same, but two, if you think about, okay, so think about in your mind, from tan to cot, if you add a co into it, add a co, so like tan becomes cotan, becomes cot, and then sec, if you do the same thing, add a co, becomes cosec. So 1 plus tan squared equals sec squared. If you add co to both tan and sec, becomes 1 plus cot squared equals cosec squared, right? So, right, so we're going to use this from now on. Now, example, with proof identities questions, students do find it difficult because there's so many directions you could go with in algebra. And that's true with proof questions. Even as a teacher myself, sometimes I do not struggle, but I see maybe I went in the wrong direction in terms of how I achieve the proof. So, and that's perfectly normal. So what I will teach you in here is how you can approach it and how you can think to get to the answer rather than telling you a fixed answer how to do this. Okay, obviously there's, by the way, there's a typo in here. It's meant to be theta in here, not x. Or you can change all of them into x, doesn't matter. Right, so proof question, you always start from one side to the other. So either left-hand side or the right-hand side. Now, first question you always ask yourself is, which side do you start from? The left-hand side or the right-hand side? Okay, and how to justify it. Now, I'll give you time, pause the video, okay? Write down if you want to start. You might want to try use a pencil as well to try and have a go at this. I start from left-hand side or right-hand side, okay? I would like to write down why, okay? Why? You have to give a reason why. Okay, so if you start from left-hand side, okay, if you start from left-hand side, now this is just a brainstorm, all right? So that's just a brainstorm. If I start from left-hand side, what you can see is you've got a cosec, so there's just a brainstorm. Cosec is the same as 1 over sine, so that's maybe one thing I can do. Cot is same as cos over sine. Okay, so that's one thing you can do. What else can we do? Now that's a hidden one, not sure if you realize that. How or 4 take away each other, that's a difference of 2 squares. So it's a difference of 2 squares. Well, how? Different 2 squares. Think about this. X to the power 4 minus y to the power 4. I can rewrite as x squared minus y squared squared. That's the same as x squared minus y squared and x squared plus y squared. Okay, so that's that's something we can start on the left hand side. What about on the right hand side? Okay, now on the right hand side, what can we do? Well, on the right hand side, we could multiply top and bottom by the what's it called? The conjugate. Well, what's conjugate? If you rationalize it, for example, if you rationalize, so for example, you've got 1 plus √3 over √3 minus 5. Now, if I ask you to rationalize this, what will we do? We will multiply top and bottom by √3 plus 5. Right? So in here, what you can do is sort of do the same thing. You can multiply top and bottom by 1 plus cos squared theta. Okay, now these are just brainstorm, okay? The best thing about proof, or the worst thing that student hates is there's so many directions. So I'm just laying out some directions you can follow. That's one way, right hand side. What about the second way? Well, something we can think about is denominator 1 minus cos squared is the same as sine squared. Right? So that's something maybe we can do as well in denominator. Right, so which one do we go? Now, in my notes, I start from left hand side. But now on top of my head, I could also start from right hand side, which actually might be the easier option as well. We'll see why. So I'll start from right hand side. Okay, so I'll start from right hand side. So I'll start from today's what I'm working out. Okay, so I'll start from right hand side. So as I said, I like to write down the right hand side once, just to tell myself in my mind what I've got. Right? Now, all I will think of is, if I start from right hand side, okay, so let's say if I choose option 1, then what will I do next? If I multiply top and bottom by 1 plus cos squared, then on the top of 1 plus cos squared theta times 1 plus cos squared theta, which does kind of give me power 4, but I will have quite a few terms on top, because if you multiply 2 brackets of squared, what you get is 3 terms. It's like you're expanding double bracket, you get 3 terms. And then, but the answer only got 2 terms. Same with denominator, 1 minus cos squared times 1 plus cos squared looks quite complicated. So maybe I'll go for the easy option. Let's start with root 2. Let's start with changing denominator into sine squared theta. Okay, so if you struggle to understand this step is 1 minus cos squared theta is same as sine squared theta. Well, where did it come from? We know sine squared plus cos squared theta equals 1. So I rearrange it. Okay, so cos squared, so sine squared equals 1 minus cos squared. Okay, what's next? Well, what would you do next step? Well, next step, what I can do in here is I can split the fraction. Right, so I can split a fraction. And why would I do that? What prompts me to think of that? Now, with proof, that's what I can do. I can teach you how to think, or what I'm thinking. What I'm thinking of is, if I split the fraction, I see 1 over sine squared. That's quite similar to cosec. So that's my thinking logic. So I'll just split it up. 1 minus sine squared theta plus cos squared theta over sine squared theta. Right? Right. So what's next then? Well, so 1 over sine squared is cosec squared theta plus cos squared over sine squared is cos squared theta. Now, if I compare my answer to the left side, I see I've got cosec, I've got cot, but the difference is, well, 1, they're power of 2 instead of power of 4, and there's a plus instead of a minus. So then in here, students usually, or even myself, will struggle to, how do I make the power bigger? It's quite difficult. And therefore, from there, I'll probably abort mission or just leave my answer like this, because I've struggled, I've run to a dead end, a cul-de-sac. So I might want to try the left-hand side and see where I can lead me to from left-hand side. Okay, so left-hand side. Okay, so in exam, you can perfectly do that. Now, these are my drafts. Okay, so that, by the way, this is working out. Next, I'm not going to cross them all out. I'm not going to cross them all out. Don't do that, because if you cross them all out, that means you are literally canceling all your working out and start a new one. You don't want to do that. These might prove to be useful. Okay, we'll see. Maybe we'll see why. Left-hand side. I'll start with left-hand side. So left-hand side is cosec to the power 4 theta minus cot to the power 4 theta. So now my draft's going to come handy here. So left-hand side, what have I got? I can change the cosec into 1 over sine, or cot into and cot equal cos over sine, or I can use different 2 squares. The first one seems the easier one. Let me try that. So cosec to the power 4 is same as 1 over sine to the power 4 theta minus cot to the power 4 theta is same as cos to the power 4 theta over sine to the power 4 theta. So then what I can do is I can simplify the 2 fractions together. 1 minus cos to the power 4 theta over sine to the power 4 theta. Now, when the power's not 2 in the top, you can't quite use the identity. Remember, sine squared theta plus cos squared equals 1. Now, you can't quite use it in here because of power 4. It doesn't work like that. So what I'm trying to say, you cannot, it's not the same as when you have sine to the power 4 plus cos to the power 4 equals 1. That doesn't work. So what can we do? Well, 1 minus cos to the power 4 theta, perhaps we can use difference of 2 squares. 1 minus, or think about like this. 1 minus x to the power 4 is same as 1 minus x squared, 1 plus x squared. Struggle to see, still struggle to see. Think about this. If I tell you, okay, 1 minus 121, what, no, actually, oops. If I tell you 1 minus x to the power 4 is same as maybe if I do x squared minus 121, then you can do x minus 11, x minus 11. So same thing in here. Now we can do this with the numerator, so that will be 1 minus cos squared theta, 1 plus cos squared theta over sine to the power 4 theta. Next, I know the top 1 minus cos squared theta, then I can apply the identity in here, so which makes it into sine squared theta times 1 plus cos squared theta over sine to the power 4 theta. So that 1 minus cos squared theta and sine squared theta. So sine squared theta over sine to the power 4 theta, I can cancel out into 1 plus cos squared theta over sine squared theta. Well, because the power, power of 2 on the top and power 4 underneath it, we can cancel down. And now, if we compare with the right-hand side, that all the things we've worked out, you can see the step, actually, one of the steps matched. Can you see that? So that's where we can say, okay, so that means we can do that. So we can use the result in here and the result in here. What it means is, therefore, the left-hand side equals the right-hand side. Proven. Okay, proven. So it seems a long way, but if I'm working in exam, I will probably do the same. There's no, it's quite hard to see from one step to the other. You must be able to try different things and to try execute it. In exam, it's not possible to see the model answer straight away. Improved question, that's the difficulty about it, or that's the beauty about it from really good mathematicians, which I hate hearing my teacher used to say, oh, math is so beautiful. That makes me puke before, but now I'm the one who makes you puke. Right, so that's what we do. Okay, so we'll try different things and see what they can mean. Now, if I want to show you the model answer way, the quickest way, okay, the quickest way is this. So that's the quickest way. Okay, so quickest way is we start from left hand side. If you want to write down, you can, but this is not probably I would suggest in the exam because it's quite hard to see where it come from. So you should different two squares in here. So cosec squared theta minus cos squared theta times cosec squared theta plus cot squared theta. So that difference of two squares. So if you struggle to understand it here, different two squares. So cosec squared theta minus cot squared theta. Now I know identity that links a cosec squared and a cot squared. The second identity, where is it? Yep. The second identity. 1 plus cot squared theta equals cosec squared theta. So if I rearrange it, oops. So since 1 plus cot squared theta equals cosec squared theta, right? So if I bring the cot squared theta right hand side, then 1 equal cosec squared theta minus cot squared theta. So therefore, this whole purple bracket equals to 1. So equals to 1 times cosec squared theta plus cot squared theta. Well, then my next thing to do is, if I look at the right hand side of the question, I need to change the back of the cos and sine. So the 1 is gone. Cosec squared is same as 1 over sine squared theta. Cot squared is same as cos squared theta over sine squared theta. If I put them together, 1 plus cos squared over sine squared theta. Use the identity, I know sine squared is same as 1 minus cos squared. That's the same as right hand side. Now that's the cleanest way to work it out, but it is proven to be quite difficult. And even I just do it on the spot. You can see what I did on the spot in here. I struggle to work it out this way, right? And that's normal, right? You're not expected to work out the perfect way for every single time. Some of the easier questions you can, but this actually this proves, pun intended, to be quite difficult. Right? Next one, proof. Okay, hopefully this will be slightly easier. Practice. Have a go at a question. Okay, remember logic, left hand side, right hand side first, and why. All right, if you struggle to see the bigger picture, then try to make some draws. Let's say, oh, which direction can I go? Okay, you're in a fork in a road. Okay, so you've got so many directions, which way to go? Try to justify, try to convince yourself that's the way to go. Okay, and why? All right, so pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, so in here, this question, I'll probably start from right hand side. The reason I want to start from right hand side is because I see a bracket. Okay, when we see a bracket, we expand it. Okay, so when we see a burger, we eat it. 1 plus sec squared theta. Okay, all right. Or when we see homework from Mr. Fan, what do? We do it. Yeah, so same thing. Expand bracket, sine squared theta plus sine squared theta, sec squared theta. Sec squared theta is same as cos squared theta, so sine squared theta over cos squared theta. Well, what do I need? Well, sine squared theta plus sine, so sine squared theta over cos squared, same as tan squared. And yeah, so equals to, so sine squared theta plus tan squared theta. Well, I'm still struggling to work out where, but sine squared, I can make sine squared into 1 minus cos squared. So now if you compare my answer to the left-hand side, I've got the negative cos squared. So 1 plus tan squared is the same as sec squared. So sec squared theta minus cos squared theta. Well, where does it come from again? So sorry, that 1 plus tan squared equals sec squared. And here, what I did was I make sine squared theta equals 1 minus cos squared theta. And then here, and then 1 plus tan squared theta equals cos squared theta. And that's the cleanest way of working out. Right? But what else can you do? You can try different ways. You can try left hand side equals right hand side and try to simplify there. Okay. Right. Example. Next one. This one is about solving equations. So to solve a trigonometric equation, you can't have 2 trigonometric functions. So in this question, you can see a cosec squared and a cot theta. You can't solve it because if you want to solve a trig equation, at the end, you will have to do the inverse. To do the inverse, you can only have 1 trig function. So in this case, we can apply our identity that 1 plus cot squared equals cosec squared. So I'm going to apply, so here I'm going to apply 1 plus cot squared theta equals cosec squared theta. So straight off, I'm going to change the cosec squared to 1 plus cot squared theta minus 9 equals cot theta. Well, why? Okay, so one question, why do we not change it to cos and sine? Because, you know, it's just unnecessary. If you change the cos and sine, you still have the cot theta. If you also, okay, what I'm trying to say is, if you change the cot theta into cos over sine, then you are still having 2 trig functions, cos and sine, rather than cosec and cot. And you don't want to do that. Okay, so the easy way out is to change the cosec squared. So think about the identity that links cosec with cot, which is 1 plus cot squared equals cosec squared. So I can do that. Expand a bracket, you should see a quadratic. So 4 plus 4 cot squared theta minus 9 minus cot theta equals 0. So 4 cot squared theta minus cot theta minus 5 equals 0. You should execute these algebra perfectly. And then what you can do is simplify the quadratic, factorize it. You should get cot theta equals to 5 over 4, or cot theta equals to -1. Cot theta is same as 1 over 10, so tan theta will equal to the reciprocal, which is 4/5, or tan theta will equal to -1 over 1, which is same as -1. Then arc10 inverse 10 on both sides. So inverse 10, so when you do theta equals inverse 10 of 4/5. If you remember what I said last lesson, to do inverse straight away, you should use a cos diagram. So you will get 38.7 degrees. It works. So for 10 to be positive, let's do here. So that theta equals 38.7 degrees, or 180 plus it, 290 degrees. What about tan theta equals inverse, so theta equals inverse 10 of -1. Put in a calculator, I believe it should give you 135 degrees. So theta equals 135 degrees. 135 degrees for 10 to be 135 is here. So where is the next value that 10 is negative? Well, in the cos quadrant. So therefore, this will also be 135 degrees. Therefore, the angle from here all the way to here is, well, you can work out this little angle is 45. So 360 minus 45 is 315 degrees. This is a cast diagram. I'm not going through too much. If you're struggling with that one, you should do more cast diagram question. Pure 1, chapter 10. Right. So next one is exam practice. All right. Pause the video. Have a go at the question. 6 marks for solving that one. When you're ready for the answer, you can press play. So here are the answers. Okay, so first of all, change 10 squared into sec squared theta minus 1 using a new identity you've learned, new toy. And then you sub it in, becomes a quadratic, simplify, etc. Then you should get sec theta equals -2 or -1. Then you do a reciprocal, not negative reciprocal. You just flip it. You don't have to add an extra minus or cancel the minus because this is not the same as the gradient of tangent normal. It's just flipping it. So cos theta equals -1/2 or cos theta equals -1. So when you put up inverse cos of -1/2 in the calculator, you can use degrees, but because they need a radian, so just do pi, and then so you get 2 pi over 3, and then use cos diagram, you get 4 pi over 3. You can work in degrees and then change it back into radians if you prefer. For the inverse cos of -1, be careful you don't use cos diagram because when you do inverse cos of -1, use a cos graph, that will be the best. You should see there's only one answer with the -1. Unlike the other values, with -1, there's only one answer. So in this case, so 3 answers, 2 pi over 3, 4 pi over 3, and pi, and 6 marks. And that's it for the lesson.